Hey guys, so today we're going to be looking at a rule called the power rule. So if I have x to the second power to the third power, let's think about what x to the second power really means right here. So x to the second power is just x times x, right? The second power means you multiply it by itself twice. And then we're going to take to the third power though, and we're going to ask, well, what does that mean? Well, x to the third power just is x times itself 3 times. So if I have x times x to the third power, that means I'm just going to do x times itself times itself again. And the number of times that I multiply it by itself is the exponent that I have. So x to the third is just x times x times x. So x times x to the third is this, what we get right here. And the question is, how many x's am I multiplying together? Well, in this example, I'm multiplying 6 of them. So my final answer can be simplified a little bit to say x to the 6th power. All right? Now, think about what we just did here. We said, well, if this is 2 x's multiplied together, and this is whatever that is multiplied together 3 times, the way we can actually get this number without doing this work is by recognizing if I just multiply these two numbers, if I have 2 groups, and then 3 of those groups of 2 groups of 3 is 6. So that gives us our power rule. So x to the a to the b power, we can find that answer and simplify it by calling it x to the a times b. So let's look at it over here. Instead of writing out all these t's, we can just recognize that if I just multiply my two exponents together, my final answer should be t to the -7th times -11. And so my final answer after I multiply those is t to the 77th power. And that's going to be my answer. Okay, so let's use this power rule in a couple more difficult examples. And so here we have a couple different variables, but our power rule is still going to be the same. It's also a rule that tells me if I have 2 bases and I raise them both to the same exponent, let's call it m, I can distribute that exponent to both of those bases, and I can do a to the m times b to the m. Right? So we can use that along with the power rule to do this here. So let's take our first one together. Let's take this x to the 11th power. And so I'm actually going to be distributing this 4th power to the x to the 11th power. So that leaves me with x to the 11th power to the 4th power. And then for our y variable, we're going to be distributing the 4 there as well. And so that's going to be y to the -7th to the 4th power. So now we can simplify this and call this x to the 11 times 4, which 11 times 4 is 44. And then y to the -7 times 4, well, that's going to be y to the -28. So you could circle your answer here, but if you happen to have some sort of a direction to use only positive exponents, you also could write your answer as x to the 44 over y to the 28, because a negative exponent is just telling me to write it on the other side of the fraction as a positive exponent. So either one of these will work as answers depending on your directions. Okay, over here we have one more. So if I go ahead and I take each individual variable, let's go ahead and treat the 4 as its own variable because it is, and that gives me 4 to the 2nd power. And then let's go in orange for the x variable. That's going to leave me with x to the 3rd power all to the 2nd power. and then red for the y variable. And then that's going to leave me with y to the 0th power to the 2nd power. And so let's simplify this down a little bit. 4 to the 2nd power, well, that's just 16. X to the 3rd power to the 2nd power, if I use my power rule, that's just 3 times 2, so it's just x to the 6th power. And then y to the 0th power to the 2nd power, well, when I multiply these two numbers, y to the 0 is what I get. And so then for my final answer, I can write it just as 16 times x to the 6th. Now remember what y to the 0th is? Anything, we'll write this up here as well, any number to the 0th power is always equal to 1. So this is really just 1. So do I need to write times 1? I could if I really want to, but I can just leave it and recognize anything times 1 is just itself. And so my final answer would be 16 times x to the 6th.